It was worse than this. I was sweating and I was just sitting there. It was really bad. All right, what I want to do is really cover one by one. This is exam 2, version 2. I'm going to cover one by one each one of the problems and save them as a video recording. So this is going to be the key for version 2. The key for version 1 is going to be an actual key. But this way you'll get to see what I kind of expect on each one and some of the changes I'm going to make in the grading. So I graded this one as the rubric was written, the one that I started handing back. Because I felt it would be unfair to change anything that the rubric has already. But I wanted to highlight certain things. So this is the angle problem where you had to fill in the angles and then answer the question of where the cosine of the angle is equal to minus square root of 3 over 2. Now I have, on the test, I have that on this problem it says answer must be in radians. Because some of you just gave degrees. I don't care if you give the degrees, feel free to give the degrees, but you have to have the radians now for this problem. And most everybody got this correct. Some of you didn't, I don't know what happened, but some of you maybe messed up the x and the y. Cosine is always the x coordinate, and y is always the y coordinate. I'm not going to go over this problem. Most everybody has the unit circle imprinted in their mind. So actually, you know what? Dr. Perzinski, who's next door to me, never laughs or anything. He came over to my office today and he said, "Is that the unit circle?" And I said, "Yeah, it is. That's the unit circle." He said, "You know what? I know this woman who had it tattooed on her leg. She actually had a tattoo of a unit circle." And I said, "You won't believe this, but I've been asking my students to do that for some time." Like, a woman actually did tattoo the unit circle onto her leg. I think it's a great conversation starter. This particular one, everybody got it right. Just to remind you, let's see. Make sure that you have everything with cosines and sines. The only issue that I saw is on somebody's test, they didn't have the x's there. And I will take full points off at this point in time of the semester if you're not putting your x's, because these things don't have meaning if they don't have the x's. You might say to yourself, what's the big deal if I don't have the x's? Well, if you go to Mukherjee's class, Calc 1, and he sees there's no x's there, he's going to think you don't know what you're doing. So really, it's like it's a sign of something that I don't want anyone to ever see. So I want to really encourage everybody to make sure they put their x's in there. This one gave people some trouble. So I'm going to go over this one a little slowly. So you're supposed to have the laws of exponents in here. Most people got the law right, but I'm asking for an example. In a video, I actually provide you with examples one by one. But all I'm looking for is something that shows how this works. So for example, 1/2 x to the 3. This is going to be x to the 1/2 plus 3, which is equal to x to the 7/2. I'm going to take points off if you put numbers in there. I need to see this with x's just the way it is here. I need to see that you can symbolically apply it. So far everybody's putting numbers in there. Put an actual letter. I don't care if it's a Y or an X or Z, because that's the way you're going to see it again. And I need to know with good faith that I'm letting you out of here with good credentials. It's my good name. That's all I have. I need to know that you do well after here. Otherwise, you have to tell me if you had Dr. Song. Okay, over here, x to the minus m, that's 1 over, again, people got the rule right. It's x to the 1 over m. An example, don't use numbers, use letters. So x to the minus 2 is equal to 1 over x squared is an example. Over here, a to the p, b to the q, r, you get a to the p, q, pr, b to the qr. And then put an example in, don't just use some numbers. What I showed you is I actually did 3x squared, something like this, y cubed to the whatever number you want to put here, 4. I did something like this in my example because some people leave off the fact that the 3 gets 1. This is really a 3 to the 1 power here. And so it also gets the 4 multiplied in. And that's why I chose that particular example. And you know what? I got to be honest with you, and I'm trying never to be judgmental, but when I see people make those kind of mistakes in Calc 1, I think, doesn't know what they're doing. They must have had Dr. Song for pre-calc. So just be careful that if you're moving on to the next class, that these aren't the mistakes you make. And it does harm you, because you don't want the person to take your test and go, oh, here she is again, Sarah's test again. You don't want them to do that. You want to always to look at whatever you're doing is, oh, this is the first test I'm going to grade because it's the best. Right? All right, the last one gave people a lot of trouble. The reason I use numbers to remember the relationship between exponentials and logs is because this is all I need to know. I don't need to know extra formulas or anything. So if, for example, I had log base a of c plus d, and I wanted to know what that implies as a exponential, well, this relationship up here with the numbers tells me where everything goes. The little a down here is the same place as the little 10. The 10 goes right here. Let me erase this here.
Why is that one on?
I'll tell you in a second. The c plus d is where the 100 goes. That's on the other side of the equal sign. The x is where the 2 goes up here. Right? So I put this example worth more because you're going to see it again. That relationship, the whole purpose of a log is to take data that's too large and to squeeze it down. People work with logs all the time in medicine and in biology and don't seem to understand that relationship. So I hope that my Georgia Tech professors don't listen to this, but I took a 400 level biology class at Georgia Tech, and they were talking about pH values. Does anybody know how pH values are calculated? They're logs of something, right? So you measure something, and then you take the log of it because this number turns out to be big. So you take the log of it. So natural rainwater, for example, has a pH value of 4. And then the East Coast rainwater is more acidic, so it has a pH value of close to 6, but it's something like 5.6 or something like that. So the professor asked a question on a test where she asked how much more acidic is rainwater in the Northeast compared to rainwater, natural rainwater. And what I did is I converted back to exponentials, and I actually calculated how many times more it is, and it turned out to be something like 38. Her multiple choice answers were 10, 50, and 100. So which one did I choose? Which one should you choose if you get the exact answer of 38? I chose 50. I got it wrong. Because what she did is she said, 5.6, I round that up to 6. 4, it's a 4. It's 100 times more. You can't do that. You can't do that. You can't round in logs and then go backwards in exponentials. This log is just a way of decomposing exponential data. So it's done all the time in biology. And that's the professor who was making that error. So I did come back to her, and I probably annoyed the hell out of her, saying that this is not correct because you can't take log data and transform it or round it. You have to go back to the original equation. So that's why this is actually the most important example, going backwards and forwards with logs. And you will see it. You will see it. What I'm going to do in the last few weeks of class, instead of actually giving you work to do, I'm going to write all the bio professors and tell them to give me real examples of stuff that they use in classes that use logs and all the different things that they use, so that when you see it again in bio class, you'll know what it is, right? If they do use it, I've used it on, I think I used Dirk Vanderklein's data. He once gave me data to actually look at. I mean, log transformations are always used. The only thing that isn't used is probably we don't use, in biology they always use log base 10. They don't use any other log. In math we always use natural log base e. So in Calc 1 you're going to get log base e. In Calc A I hope you get log base 10 because that's supposed to be the BioCalc, but you may not. So it depends on the class. But we usually, like as a mathematician, I always use log base e, ln. But in bio you always get log 10 with the log base 10. So you don't get these weird this will always be 10 you if you're gonna take bio and not gonna take any more math classes.
Did she ever fix your grade? Did she ever give you that point on the test?
She did, but she was not happy. That was like the second or third time that I came in there for something.